percent composition, except this time you're not going to have to look at a chemical formula and use molar masses of the individual elements and divide by the molar mass of the entire compound. We're going to do it slightly different. We're still looking for that percent composition, meaning that part divided by the whole. And our goal is to get a percent of each element in that compound. Except this time, if you look at my question, I don't see a chemical formula anywhere. But what I do have is a lot of mass information, which is very super handy, because the goal is to use the mass of the individual elements and divide it by the whole mass of the substance. The substance we're talking about here is cast iron. All right, cast iron is made up of 4 different elements. So we're going to look for the percent composition of those 4 elements that make up cast iron. This is the whole that is basically going to be these 4 substances. So what we're going to do is we're going to look at the fact that we have this many grams of this substance, so 1.68 grams of carbon, 0.24 grams of manganese, 0.576 grams of silicon, and finally, we've got 45.504 grams of iron. So there's your 4 elements that make up cast iron. Now, you're asking yourself, how do I figure out what's the whole that I'm working with? Because I've got all my individual parts of mass. What's my whole? Well, simply add up all the masses that you're given, and you should have the whole substance mass. So if I added up 1.68 plus 0.24 plus 0.576 plus 45.504, that total mass should equal 48 grams. All right, 48 grams of cast iron. That's your cast iron. All right, so that's easy. The rest should be pretty simple. You're going to come down here and you're going to list every one of your elements that make up cast iron. All right, so we have carbon, manganese, silicon, and iron. All right, and we're going to take those mass information. So for carbon, we have 1.68 grams. For manganese, I have 0.24 grams. For silicon, I have 0.576 grams. And for iron, I have 45.504. All right, remember, the total mass is based on all 4 of these added together. And that gives me that total number of 48 grams. So I'm going to take his part mass and divide it by the whole mass. And I'm going to do that for every one of my elements that make up cast iron. All right. Now before I get my percents here, because I'm going to finish setting up my problem, add my brackets. Because remember, in order to get a percent, I need to make sure I multiply by 100. Because if you don't, you'll be reporting the decimal form. All right. I just want you to analyze your data. Looking at these 4 different masses, you can instinctively tell which of these 4 is going to make up the larger percent of cast iron. That just means look at the amounts you're given, who's got the bigger amount of mass between the 4 of them. And if you look at them, I bet you can easily pick it out. That would be iron. So I'm expecting iron to have a really high percent composition number. I'm expecting manganese to be a very low percent composition number. And actually, when I do the math, it works out. So I take his part, carbon, divided by cast iron's mass times 100, and that gives me 3.5%. Right? Manganese, as I predicted, take his mass divided by the whole cast iron mass times 100, gives me a meager 0.5%. Silicon, take his mass divided by the whole mass of cast iron, and that gives me 1.2. So these are all still pretty small percentages composition, and I'm expecting this guy to be a really big one. When I do this math, it actually turns out to be 94.8%. 48% mass. And if I add them all up, give me a second. All right, that's 10, 10, gives me 0. 20 comes up here, so that tells me I've got 4, 5, 6, 7, 8, 9, 10. And then that brings me up to 100%. So it all adds up to 100%. Each one of the elements should add up to 100%. All right? And that's what happens when you're given mass information and you're asked to find the percent composition of each element to the whole.